Hello from ChemHelp ASAP. In this video we'll discuss just briefly some reaction consequences, how the octet rule works with effective nuclear charge and how we can use these to understand how chemical reactions occur and sometimes don't occur. Okay, so to have this discussion, let's talk about fluorine. Fluorine has an electronic configuration which consists of helium and then 2s2 and 2p5. And if you simply Google electronic configuration of fluorine, you will find this written down. Now, remember, helium, sometimes we put the atom in brackets, but with this, the full configuration is 1s2, 2s2, 2p5. So you'll see both these styles of notation of electronic configuration. So let's look at the atom itself. So here this dot represents fluorine. We have 9 protons, and this is fluorine, the atom. And we have 2 shells, shell 1, shell 2. In our first shell, 1s2, we have 2 electrons. And in our second shell, we have 7 electrons, our 2s2 and 2p5. That's 2 plus 5 electrons, 7 electrons. There we go. Try to fit them all in. That's 7 electrons. What is the effective nuclear charge of fluorine? Well, it is Z, the atomic number, take away the number of shielding electrons. The atomic number is 9. That means we have 9 protons. Take away 2, the first shell electrons, and we get a number of 7. Great. This is a really high number. This explains why fluorine is so electronegative, and it really wants to attract in another electron. So let's give it that electron. Now we'll look at fluorine minus. Again, dot, that's the nucleus with 9 protons. 2 shells, still have 2 electrons in the second shell. Now we're going to have 8 electrons. We added an electron. 1, 2, 3, 4, 5, 6, 7, 8. Okay, what is the effective nuclear charge for fluoride? Well, using our simple formula, and candidly this is a very simplified formula, but we're going to use it. It's Z minus S. These values are the same. The atomic number, the number of protons in the nucleus, still 9. And the number of shielding electrons, non-valence electrons, is still 2. And so the effective nuclear charge for our valence electrons, all 8 of them now, is still 7. Well, if fluorine still has such a great effective nuclear charge, let's give it yet another electron. So this is going to be fluorine minus 2. Draw out the atom. Still have 9 protons. Now we have our first shell. That's got 2 electrons. Our second shell, it already has 8 electrons. So this last electron cannot go into the second shell. That's what the octet rule says. So that last electron has to go into a new shell, shell 3. So let's determine the effective nuclear charge for the valence electrons in this structure. Well, the formula is the same. The atomic number is the same. Number of protons is unchanged. But now the value for S has changed. Remember, these are our shielding electrons. And our shielding electrons are our non-valence electrons. Well, that includes all the electrons in shells 1 and 2. And now that is a total of 10 electrons. So that's a change. We calculate our effective nuclear charge, and it's minus 1. So how happy is this extra electron that has been thrown into the third shell? Not at all, because it basically has no view of any protons from the valence shell. It has a negative effective nuclear charge. So this electron will not be happy, and it will not go into valence shell, and fluoride will never pick up an extra electron to become fluoride minus 2. So the octet rule and ideas like effective nuclear charge, they work together and help us understand why elements maybe attract an electron, and then in some cases, why doesn't an element attract another electron? When fluoride has enough, it's had enough, and that's driven by the octet rule and our valence electron count and effective nuclear charge.